In this video, you'll learn how to use audio reactive behaviors to drive animation effects with audio. To get started, let's open the included audio reactive tutorial scene. This already has the audio track and spectrum configured, covered in the previous video, as well as some additional objects to work with. Let's select and view the sphere object in the Timeflow view. We can right-click to add audio, audio reactive, and then for a basic example, select local position Y. This adds the new audio reactive behavior and automatically assigns an audio sample as input. This provides the input data that drives the behavior, and you may of course assign a different sample by dragging and dropping the object into the field. For this one, we'll use sample low. We can play Timeflow to preview the results so far. This behavior works similar to tween, but has some unique features for audio processing. The value min and max fields sets the starting and ending values applied to the target property, driven by the audio amplitude. We can also change the overall scale, multiplying the output value. And there are a number of different interpolation modes to select from. The attack value sets the time in seconds it takes for the value to ramp up to full intensity. This has the effect of softening the movement when audio input is detected. However, if attack is set too high, then the perceptual relationship to the music is lost, so it's best to use a low value or set it to 0 for an immediate response. Let's set it to a value of 0.1 to soften the attack just a little bit. Next is the release value, which determines the time in seconds it takes for the motion to return to its resting or minimum value once audio input is no longer detected. A longer release time sustains the effect overall, but making it too long can have a dampening effect. To keep the overall animation somewhat punchy, let's set the release to 0.5 seconds. The multiply value is applied to the audio input to exaggerate or diminish the reactive effect overall, which we can leave at default. And lastly, the clip setting can be used as a gate filter, defining a value from 0 to 1. Any audio amplitude values below the clip threshold are ignored, essentially filtering out low-level noise. As a side note, when working with audio spectrum analysis, there is inevitably some bleed over across frequency ranges. It can be difficult or impossible sometimes to isolate a specific sound entirely, but you can usually get close by adjusting the clip settings and input frequency ranges of the audio sample. We could also try setting the sample mode to maximum to make it a bit more dynamic. For an alternate approach that offers greater accuracy for audio reactive effects, see the next tutorial on using MIDI. The amount slider may be used to control the overall audio reactive effect, blending it down to its minimum value. And finally, we have override. This can be used to directly set the final output value, either using animation or a script to transition the audio reactive behavior on and off over time. Now let's see how audio reactive behaviors could be used to animate materials. For this one, let's add the icosahedron object to the view, and once again right-click to add audio, audio reactive. Though this time, let's select the material property, emission color. If sample mid is not already assigned, drag and drop it in from the hierarchy view. We can then set the start and end colors and preview the results. When working with color properties, you may also use the multiplier field to intensify the color to make it brighter. Another useful tip when using audio reactive behaviors is that the output channel may be linked to other channels to drive additional properties. As a quick example, with both the icosahedron and sphere objects in the view, we can drag the icosahedron object onto the link well of the sphere's local position channel. This adds a new local position channel to the icosahedron and links it to the sphere so that they now move together. One caveat to using audio reactive channels is that audio processing only occurs at the current time, so it is not possible to use time offsets with the links, and entering a time offset value has no effect. Though we can additionally process the data, for example by setting a keyframe value of 1 and setting the link mode to subtract. This is of course just an example and there are endless possibilities. For the final object, we'll add the octahedron to the view and follow the same steps as before to apply the audio reactive behavior. For this one, let's select the local scale combined value, and drag and drop sample high to assign the input. And then enter some scale values to squash and stretch the object. Note that at any time, you can assign a different property mapping and add as many audio reactive effects as you wish. That concludes this tutorial on audio reactive behaviors. Please refer to the documentation links in the video description below for further information. Next up, we'll go over using MIDI.